Rajaji National Park is defined by its towering sal forests and deep, rugged ravines. Moving silently through this cover is a dense population of one of the world's most elusive predators, the Indian leopard. Within specific western ranges like Modichur and Mohand, the population now exceeds 250 individuals. The dappled camouflage provided by the forest floor makes these sounds a premier stronghold for the species. By any ecological measure, this growth is a significant achievement. Yet this success directly triggered a lethal conflict between predators and local communities. Between 2014 and 2017, the tension escalated into a crisis. Localized leopards began actively hunting humans in the outskirts of the park. These attacks centered on a specific geographical fault line, National Highway 58, a major transit route that cuts directly through the high-density Modichur range. The conflict resulted in over a dozen human fatalities, including a forest range section officer. In just 5 months during 2017, authorities were forced to capture 4 separate leopards identified as man-eaters. To understand why a highway became a hunting ground, we have to deconstruct the mechanics of ecological release, the behavioral shifts of the predators, and the structural failures of linear infrastructure. When conservation success is not spatially integrated with human development, the borders of protected areas turn into fatal friction points. Historically, Rajaji's western tracts have maintained a low density of Bengal tigers, the landscape's dominant apex predator. This chart illustrates the principle of Mesopredator Release. When the top-tier predator, the tiger, is absent or rare, the top-down pressure on middle-tier predators like leopards disappears. This allows their numbers to expand horizontally across the landscape. But population growth also requires a stable food supply. For 2 centuries, the Gujar pastoralists kept thousands of domestic cattle in the park, which severely overgrazed the forest floor. This competition for resources ended with the voluntary relocation of the Gujar community, which removed the grazing pressure from 7 of the park's 9 forest ranges. Without cattle eating the understory, the sal forest architecture regenerated. This created a highly productive environment with massive spatial capacity for wildlife. This botanical recovery led to an immediate increase in the carrying capacity for wild deer and other ungulates. This line graph shows the correlation. As the wild prey base recovered, the lack of competition from tigers acted as an engine for leopard growth. Their population followed a steep exponential upward curve. As the population reached its peak density, the cats began to outworld the park's core, pushing individual leopards outward toward the human-dominated boundaries. Restoring the habitat solved one ecological problem, but it inadvertently created a dense predator population that exceeded the physical limits of the sanctuary. Unlike more specialized predators, leopards possess extreme behavioral plasticity. They are highly capable of navigating and exploiting human-modified environments. In Rajaji, they display opportunistic hunting habits, such as scavenging scraps from hawk eagles or being followed by jackals through the forest at night. This plasticity allows them to use the agricultural lands bordering the park as a secondary habitat. This chart tracks seasonal habitat use. During pre-monsoon, leopards move into tall sugarcane crops at the park's edge for cover. Upon harvest, they lose their camouflage, forcing a retreat back into the forest, bringing them into frequent contact with humans. Spending months raising cubs within earshot of tractors and farmers habituates these cats to human noise. This proximity desensitizes them to anthropogenic environments. This pie chart shows the dietary result of that habituation. In peri-urban areas, 33% of the leopard's prey biomass consists of domestic animals like dogs and livestock. This reliance on domestic prey turns agricultural borders into ecological traps, habituating wild predators to the presence and the scent of humans. This habituation reached a lethal threshold along National Highway 58, where the dense forest edge sits just meters from the paved road. Between 2014 and 2017, the highway was undergoing an extensive 4-lane expansion project. The construction created severe traffic bottlenecks. Vehicles were often trapped in jams at dusk, exactly when leopard activity is at its highest. Travelers, unaware of predator density, frequently stepped out of cars in these traffic jams, placing themselves directly in the ambush zone of habituated cats. While it is tempting to view these attacks as the work of prime, healthy predators, the physical evidence suggests otherwise. Camera trap data and veterinary exams of the captured leopards revealed severe physical degradation in almost every case. These man-eaters were predominantly old or diseased, with one individual suffering from a visibly swollen throat. These injuries have a mechanical consequence. A leopard with an injured throat or limb cannot chase down a swift wild ungulate like this cheetah. Facing starvation, these compromised predators target the slowest and most oblivious prey available in the highway traffic jams: humans. The NH-58 crisis was the tragic collision of diseased predators and unprotected humans pushed to the absolute margins of the park. To avoid repeating the failure of NH-58, authorities took a proactive, scientific approach to the newer Delhi-Dehradun Expressway. The new route initially threatened to permanently sever a vital wildlife corridor linking Rajaji to the broader Terai Arc landscape. The National Highways Authority and the Wildlife Institute of India worked together to design a structural solution that maintained habitat connectivity. The result is an 18-kilometer stretch featuring a 12-kilometer elevated wildlife corridor, the longest purpose-built structure of its kind in Asia. This blueprint shows the engineering. 11 kilometers of underpasses feature 200-meter spans designed for elephant herds. But physical space isn't enough. To prevent wildlife from abandoning the corridor, structural side screens block engine noise and headlight glare that disturb nocturnal animals. True ecological permeability requires mitigating both the physical barrier of the road and the sensory pollution generated by traffic. A camera trap study titled Landscapes Reconnected provided the first real-world data on the corridor's performance. In just 40 days, the study recorded over 40,400 individual wildlife crossings through the underpasses. 18 different species use the structure, including elephants, sambar deer, and golden jackals. Megafauna and mesopredators traverse the landscape without encountering human traffic. This engineering has also reduced the transit time between Delhi and Dehradun from 6 hours to just 2.5, without increasing the risk of animal strikes or conflict. The survival of predators in the 21st century relies on landscapes like these, where high-speed human development and ancient ecological pathways are integrated into a single functional design.